Okay. So let's just start by looking at the last digit. There's no hope of computing this, right?
No.
No. So we have to get lucky with the math and just see. So let's look at the last digit of powers of 3.
So 3 to the 0.
Well, let's start at 3 to the 1 because it gets confusing with even numbers. 3 to the 1 is?
It's 3. Yeah. 3 squared is 9.
3 squared is 9. Remember, we're just going to look at the last digit. 3 to the cubed
is 7.
The last digit is 7 because this is 27.
Yeah. And then
3 to the 4th
ends in 1.
Because it's 81.
because it's 81. And that means 3 to the 5th
You can just multiply this by 3.
is going to end in what?
A 3.
3. So it repeats. And how many numbers does it take to repeat?
4 numbers. Yep.
How many?
4.
4.
3971.
3971. Then it's going to go 3971, 3971 on the last digit.
Yeah.
And maybe that's going to be helpful for us.
Well, if we could figure out 3 to what power it is.
Yeah. Yeah, and in fact, we only need to know what power it is in a cycle of 4. Okay?
Yeah.
Because if this power ends in a 1 mod 4, it's going to be 3. The last digit will be 3. If it ends in a 2, if it's a 2 mod 4, remainder is 2 when you divide by 4,
Yeah.
it's going to end in a 9. If it's a remainder of 3, when you
My 4.
divide by 4, it's a 7, and if it's divisible by 4, you get a 1. So we have this huge tower of powers of 3. So can you say anything about this power of 3? Anything at all about that number? 3 to the 3 to the 3 to the 3. The power that 3 is 2 to get Graham's number.
Well, we don't know how many 3s are in
Right, we don't know how many 3's that are in it, so it's hard to say anything about it. But you can actually say some simple things.
Well, this is
It's an odd number.
Ooh.
because
Why?
all
Well, because all of these, because in this pattern, all of the last digits are odd numbers.
Ah. Power's odd. That's interesting. Can we say even more then?
well, then the power, then the 3, and our result that the 3 to the odd power is going to be odd.
3 to the odd power is going to be odd. We're looking at trying to figure out what this power is mod 4. Or what's the remainder when you divide by 4? Since the number is odd, does that restrict any of the remainders?
It restricts this one.
This one here?
Yeah,
And perhaps the 3 squared, too.
Okay.
because they're even. The powers are even.
Right. Can it be 1, 2, 3, or 4, the remainder when you divide by 4? Well, it can't be 4 because that would be divisible by 4.
Yeah.
And if a number is divisible by 4, it's
Even.
even. Can it be 2? Can the remainder be 2 when you divide by
It
4?
would be still even.
The number would be even. So actually we've eliminated 2 remainders mod 4. So we know now the last digit of Graham's number is either 7
Or 3.
or 3.
Wow.
Wow.
Just from that.
Just from that. So let's see if we can figure it out now by computing. 3 to the 3.
Well, that's going to be a 9.
It's 27.
Okay, and what is 27 when you take the remainder when you divide by 4?
Well, 28 is divisible by 4, so
Okay.
it will be
Remainder.
3.
The remainder is 3. So if I start looking at all these powers coming down the chain, what they are mod 4, 3 to the 3
Is
the same as 3 mod 4. So I can erase this and replace it with a 3. Now I come down the chain, and now I have a 3 to the 3 again.
So 7 again.
So I get 27 when I take 3 to the 3. I take what is the power, and now I look 27. I'm not looking for the last digit, I'm looking for what that power is. 3 to the 3 is
It's 27.
27. And what is that when I divide by 4? What's the remainder?
It's 3 again.
3 again. So I can erase this power and replace it with a 3. Now I have to evaluate.
It's the exact same thing.
So
So what's going to happen?
You're
it's eventually
going
going to get down to
threes.
3 to the 3.
Which is
27.
27. So
Seven.
what's the last digit of Graham's number?
7. And we figured.
7. We just figured out the last digit.
Wow.
Whoa.
No.
Okay. Now we're going to have to go to the computer to figure out the tens digit, okay?
Right.